Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 11th, 2025, about 1 week ago. The standout result is that humanoid robots can learn new manipulation tasks from just 1 to 3 human video examples, achieving roughly twofold higher real-world success than prior video conditioned methods. The paper is titled MimicDroid in Context Learning for Humanoid Robot Manipulation from Human Play Videos. And as we will see later, the implications for robot training are quite significant. In short, it learns purely from unlabeled human play videos, bridges human to robot differences through pose retargeting and visual masking, and consistently outperforms fine-tuning baselines. On X, posts highlight quick adaptation from human play videos, risk pose retargeting, and 2 times higher success than prior video conditioned methods, with one video garnering strong engagement at roughly 96 likes. Alright, the previous item highlighted the twofold real-world gains. Figure 1 now lays out the pipeline, which starts with training on unlabeled human play videos and ends with few shot testing on novel tasks. The left panel shows retrieval of similar manipulation behaviors and conditioning, MimicDroid on those segments so it learns to predict human wrist actions. The right panel shows test time, where human video demonstrations guide the humanoid, and the execution history updates the context because the policy adapts in context rather than changing parameters. The previous figure sketched the end-to-end flow. Figure 2 details the method, which first retrieves similar manipulation behaviors from long human play videos, and then meta-trains a long context transformer policy for in-context learning. The bottom panel illustrates segment retrieval scored by observation and action similarity, so the top case segments become the context. The right inset shows feature extraction with visual masking and hand pose estimation feeding attention pooling. The top panel shows the policy predicting future wrist actions from context and target segments under a behavior cloning loss. Alright, the previous figure detailed the training mechanics. Figure 4 presents the simulation benchmark, which starts with long human play in 8 kitchen scenes with 30 objects and progresses to stronger generalization. The left panel shows the training play environment and the continuous play trajectory. The 3 right panels define levels L1 to L3. Seen objects in environment with a baguette goal, unseen objects with an apple goal, and unseen objects plus unseen environments with a broccoli on the microwave goal, so difficulty increases systematically. Okay, the previous figure set up the benchmark levels. Table I reports success rates across the abstract hand, and the GR1 humanoid for L1 to L3. The standout is MimicDroid, which leads in most cells, reaching 0.73 in abstract L1 and 0.59 in GR1 L1, with 0.26 even at L3. The row without visual masking drops notably on GR1, which signals that masking helps bridge the visual gap between humans and robots. So the previous table compared methods across levels. Figure 8 shows how success on GR1 scales with more human play frames, which matters because data efficiency drives practicality. The L1 curve rises from roughly 0.05 at 64K to 0.59 at 320K, while L2 climbs to about 0.45. L3 improves more modestly, leveling near 0.27, which signals persistent difficulty with unseen objects and scenes. The overall trend indicates steady gains from 64K to 320K, with a slight mid-range dip only on L1 around 256K. Wrapping up, 2 takeaways stand out. First, learning from unlabeled human play with in-context, learning delivers fast few shot adaptation, roughly doubling real-world success. Second, wrist pose retargeting plus visual masking bridges the human to robot gap, so the policy transfers. The broader implication is scalable robot training from everyday videos. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.